Picture this: a quiet night at the observatory, a telescope sweeping across the sky like a cosmic security camera, when suddenly something odd blips into view. Not just another asteroid, not a comet behaving badly, but something different. It's fast, it's bright, and most importantly, it's moving in a way that screams, "I don't live here." Astronomers around the world sit up straighter. Coffee cups pause mid-air. Data scrolls down the screen, and the numbers don't lie. The object's trajectory isn't the usual gentle loop of a body orbiting the sun. It's hyperbolic. That means one thing: this visitor came from beyond our solar system. A literal outsider, flying through our celestial backyard on its way somewhere else entirely. This, they realize, is 3IATLAS, the third confirmed interstellar object ever detected by humanity. The I stands for interstellar, and Atlas refers to the telescope system that caught it, the Asteroid Terrestrial Impact Last Alert System. In other words, a machine built to spot dangerous rocks heading toward Earth accidentally stumbled upon a rock heading from another star. It's like installing a burglar alarm and discovering your first alert is from a guest who broke in just to say hello. Good evening, curious minds. Science doesn't need to shout to be fascinating. Sometimes it's best enjoyed the way you'd enjoy a late-night conversation, quietly with a cup of tea and maybe the soft hum of a fan in the background. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing. No pressure. Only if you enjoy these calm journeys through the universe. Now, let's begin. The moment felt oddly familiar. Astronomers had been here before, twice in fact. First came Oumuamua in 2017, that long, tumbling enigma that everyone briefly hoped was an alien probe. Then came Borisov in 2019, a comet with an interstellar passport that behaved more like something we could actually understand. And now, just a few years later, the cosmos had done it again. A third visitor, another messenger from the stars, each one whispering secrets from a different corner of the galaxy. If the universe were a person, this would be the part where it smirks and says, "You think I'm done surprising you?" Because 3IATLAS didn't just appear. It arrived at the perfect moment. By 2024, when Atlas spotted it, astronomers had better tools, faster data analysis, and sharper instincts. Oumuamua had left everyone scrambling to understand what they'd just seen, like catching a glimpse of a mysterious stranger at a party who vanishes before you can ask their name. Borisov taught us how to watch carefully without blinking. But 3IATLAS? This time, we were ready with the cosmic cameras rolling. Now, to grasp just how extraordinary this is, imagine tossing a handful of pebbles into a river. Most will swirl around, pulled by the water's flow, orbiting the same way. But every now and then, one bounces in from the shore, thrown by someone upstream, with its own direction, its own story. That's what 3IATLAS represents. An outsider stone skipping through the solar current. a traveler carrying the dust and ice of another sun. It's funny to think that in all of human history, our species has catalogued millions of objects within our solar system: asteroids, comets, icy rocks, space junk, yet only 3 have been confirmed as visitors from somewhere else. And this third one appeared at a time when we could actually study it properly. You could almost say the timing was poetic or suspiciously well-planned, depending on how many science fiction movies you've seen. The discovery itself unfolded quietly at first. The ATLAS survey team, designed to spot Earth-threatening asteroids, noticed an object moving a bit too quickly, its path too stretched. Astronomers cross-checked the data and realized it wasn't gravitationally bound to the sun. It was just passing through. Cue a global flurry of telescope time requests. Within hours, observatories from Hawaii to Chile were pointed toward this tiny traveler. After all, interstellar visitors don't send calendar invites. They show up unannounced and leave just as abruptly. What made the moment thrilling wasn't just the rarity, it was the sheer implication. Each interstellar object that zips through our system isn't just a rock. It's a physical fragment of another world. Maybe it formed around a star we'll never see again. Maybe it once orbited a planet that's long gone. Every atom in it carries the fingerprints of another sun's chemistry. For astronomers, this is as close as you can get to touching another star system without building a starship. And yet, 3IATLAS came and went with cosmic indifference. It wasn't here for us. It wasn't performing for the cameras. It was just one of countless drifters, thrown loose from its home system perhaps millions or billions of years ago. Maybe it was ejected by a gravitational dance between giant planets, or the collapse of a young solar nebula. Whatever the cause, it had been journeying through interstellar space ever since, frozen, silent, alone, until our sun's gravity pulled it briefly into view. That's the staggering thing about astronomy. Sometimes, the biggest revelations come from objects that couldn't care less about being observed. 3IATLAS didn't need to know we existed to rewrite our understanding of the galaxy. It was a reminder that our solar system isn't an isolated island. It's part of a galactic highway where materials, energy, and maybe even the ingredients of life constantly cross paths. In a way, 3IATLAS was the universe's way of saying, you're not as alone as you think. Because every time one of these travelers appears, it proves that star systems like ours aren't sealed bubbles. We're part of a cosmic ecosystem where pieces of one world can drift into another, where a comet born under a foreign sun can end up sparkling in our night sky. So when astronomers confirmed that ATLAS had spotted something interstellar, it wasn't just another scientific footnote. It was a reminder that space, vast and cold as it may seem, is full of travelers carrying stories. Stories older than our planet, crossing light years just to say hello. Or, as one astronomer quipped during a live briefing, it's like the universe knocked on our door again, this time without even pretending to be from the neighborhood. And once we opened that door, what we found changed everything. The story of how 3IATLAS was discovered begins, fittingly, with a system designed to save us from cosmic trouble. The asteroid terrestrial impact Last Alert System, or ATLAS, wasn't built to find interstellar visitors. It was built to find threats. You know, the kind of end of the dinosaurs events we'd really rather get a heads up about. Every night, this network of robotic telescopes in Hawaii and Chile scans the sky, hunting for faint, fast-moving dots that could, theoretically, ruin everyone's week. But in this case, instead of finding a doomsday rock, Atlas stumbled upon a traveler that was just passing through. On an ordinary night, its sensitive cameras picked up a faint smudge moving across the star field a little too quickly, at an angle that didn't fit the neat geometry of our solar system. A few hours later, the automated software flagged it for human eyes. Then came the "wait a minute" moment. Astronomers checked the motion again, recalculated the orbit, and realized the numbers made no sense. Here's the thing. Most objects in our solar system trace neat ellipses around the sun, obeying Kepler's laws like well-trained celestial citizens. But this new object wasn't obeying at all. Its orbit wasn't an ellipse. It wasn't even a long-stretched oval like a typical comet's path. It was hyperbolic, meaning its trajectory didn't loop back around. It came in once and was leaving forever. The math didn't describe a visitor returning home, but a stranger speeding through town with no intention of stopping. When astronomers say hyperbolic, they're talking about a specific shape of orbit, one that looks like an open curve rather than a closed loop. You can picture it as the cosmic version of a slingshot. A rock from interstellar space zips close to the sun, gets tugged by its gravity, and then continues on its way out, never to return. The key measurement here is something called eccentricity. If an orbit's eccentricity is less than 1, it's elliptical. Equal to 1, it's a perfect parabola. But if it's greater than 1, game over. That thing isn't from here. It's just visiting. The first time scientists calculated 3IATLAS's eccentricity, it came out comfortably greater than 1. Cue the collective gasp. This wasn't another asteroid playing tag around the sun. This was something that had been traveling for light years before accidentally crossing paths with us. Its trajectory screamed, "I don't belong here," louder than a tourist wearing socks with sandals. And what a traveler it was! Based on its motion, 3IATLAS entered our solar system from the direction of the constellation Sculptor, slicing through space at over 30 kilometers per second relative to the sun. That's more than 100,000 kilometers per hour, fast enough to go from Earth to the Moon in about 4 hours, or to make you feel really bad about your morning commute. The detection triggered a flurry of activity. Astronomers at the Pan-STARRS Observatory in Hawaii, always quick on the draw, swung their powerful telescopes to get follow-up images. So did observatories across the world, from the European Space Agency's stations to backyard astronomers armed with surprisingly powerful equipment. Everyone wanted a piece of this cosmic mystery before it faded into the black. Now, catching something moving this fast isn't easy. Imagine trying to photograph a speeding bullet while standing on a rotating, wobbling platform. That's roughly what astronomers deal with. Earth's rotation shifts the stars in the background. The telescope must constantly adjust, and the object itself is dimmer than most people's imagination of visible. But still, frame by frame, they captured it, a faint dot darting across the cosmos like it had somewhere more important to be. Once the orbit was confirmed, scientists began running simulations backward in time, tracing 3IATLAS's path through space to figure out where it might have come from. The results? Nowhere specific. The galaxy is so vast and the object's journey so long that any trace of its original star system was lost to the chaos of gravitational nudges over millions of years. It could have come from a young star system ejecting debris, or a dying one shedding its icy remnants. We'll probably never know. But that uncertainty is part of the thrill. It's a literal message from the unknown. There's a certain poetry in how we discovered it. Think about it. A telescope designed to look out for danger ends up finding wonder instead. Humanity built Atlas to scan the skies for potential disasters, but the universe had other plans, like handing us a galactic souvenir instead of a meteorite warning. It's almost as if the cosmos said, "Relax, I'm not throwing anything at you today. Here's something fascinating instead." The realization that we had caught another interstellar object so soon after Borisov also hit hard. For centuries, the idea of detecting something from another star seemed impossible. The distances were too vast, the chances too small. Yet, here we were, our third interstellar encounter in just a few short years. That's not luck. That's evolution in how we look at the sky. Our telescopes had become so sensitive, our surveys so automated, that even the fastest cosmic bullets can't sneak past us anymore. And the more we find, the more we realize how many might have come and gone unnoticed in the past. For all we know, interstellar objects have been visiting for billions of years, weaving through the planets like cosmic commuters. We just never saw them because we weren't watching closely enough. But 3IATLAS changed that. It proved that our new generation of telescopes, the all-seeing, all-night sentinels, like Atlas and Pan-STARRS, are more than just asteroid alarms. They're interstellar catchers in the cosmic rye, spotting brief flickers of alien worlds as they zip through our corner of the galaxy. And maybe that's the most astonishing part. The universe didn't send us a letter, a radio signal, or a glowing UFO hovering over a cornfield. It sent a rock, a tiny, icy messenger from the stars that didn't say a word, but spoke volumes in motion, speed, and trajectory. When astronomers realized what it was, there was a quiet kind of awe in observatories across the planet. They had caught a traveler mid-flight, not from our sun, not from any planet we know, but from out there, from the unimaginable vastness between the stars. A cosmic bullet, yes, but one that, instead of destruction, carried knowledge. It wasn't aimed at us. It just happened to pass through our neighborhood on its endless journey, giving us a fleeting glimpse of something ancient, alien, and unrepeatable. And just like that, Earth had front row seats to the universe's greatest passing show. When astronomers first spotted the strange object hurtling through our solar system, the excitement was immediate. But the question that followed was almost comical in its simplicity. So, what do we call it? It's one of the most human moments in science. We can measure the trajectory of a rock billions of kilometers away, calculate its orbit with absurd precision, even estimate its chemical makeup by studying faint colors in its light. But naming it? That's the part that feels like trying to pick a baby name after an all-nighter. And this particular newborn came with some baggage. Its official name, 3IATLAS, might sound like something you'd find in a Wi-Fi password, but it's packed with meaning. The 3I marks it as the third interstellar object ever discovered. The I literally stands for interstellar, as in not from around here. Before it, we had 1E Oumuamua, then 2 Borisov, and now our cosmic hat trick, 3I Atlas. Simple, systematic, but with just enough personality to make astronomers grin. Then comes the second half, Atlas. That part honors the telescope system that discovered it, the asteroid terrestrial impact last alert system. The name sounds heroic, and it should. It's a network of robotic eyes scanning the sky every night to catch potential asteroid threats before they catch us. Think of it as humanity's cosmic early warning system, our interplanetary smoke detector. And, ironically, that same vigilance for danger is what led us to find wonder instead. The telescope's name, Atlas, itself comes from Greek mythology, the titan who carried the heavens on his shoulders. You can almost imagine the astronomers chuckling when the system's naming committee picked that one. "We're literally holding up the sky," someone probably said, half joking, half serious. And now, years later, Atlas lived up to its mythological reputation by spotting something from the heavens that no one expected. But back to the naming. Astronomical naming conventions are part art, part bureaucracy, and part inside joke. The International Astronomical Union, IAU, a group of experts who make sure celestial objects aren't named Spacey McSpaceface, oversees most of it. There's a structure. First, you describe what kind of object it is. In this case, interstellar. Then you add a number to mark its order of discovery. Finally, you append the name of the person, team, or survey that found it. Voila! 3I Atlas. A cosmic roll call entry for something older than Earth itself. It's a tidy scientific label for something profoundly untidy and poetic. A rock from another star system doesn't care what we call it. But to humans, names are anchors. They make the incomprehensible feel familiar. You can't invite Object C 2024A3 into your imagination. But 3IATLAS? That sounds like something you might actually root for. There's something endearing about how astronomers handle this part. They can spend their nights processing terabytes of data, yet still light up when they get naming rights. It's their little piece of immortality, a signature scrawled across the cosmos. When you discover something that no one in history has ever seen, you get to christen it. And just like parents, astronomers sometimes get sentimental, sometimes clever, and sometimes a little weird. Take Oumuamua, for instance. Its name means a messenger from afar arriving first in Hawaiian. Beautiful, right? A perfect poetic nod to its origins and the Hawaiian observatory that found it. Then you have Borisov, named after the amateur astronomer Gennady Borisov, who discovered it himself. Straightforward, humble, and deeply human. But Atlas? Well, this time, the machine got the credit. The telescope's name stuck, and so the cosmic visitor became a monument to human technology instead of human hands. And that feels strangely appropriate. After all, 3IATLAS wasn't spotted through a serendipitous glance or lucky stargazer's moment. It was caught by an algorithm, a pattern-hunting system that doesn't blink. It's a discovery born out of automation, data science, and relentless monitoring of the heavens. A telescope named for a titan, now finding a rock from another star? You can't script better symbolism than that. Astronomers, though, couldn't resist a chuckle. Someone joked that Atlas was the only name big enough for something that literally crossed the galaxy to visit us. Others pointed out that the acronym conveniently sounds like a Greek god anyway. Some people name their pets after Greek gods, one researcher said. Astronomers name rogue space rocks after telescopes. Close enough. But there's also a subtle truth buried in that humor. The act of naming connects us emotionally to the cosmos. It turns a string of numbers and coordinates into a story. When we call something 3IATLAS, we're not just labeling it. We're claiming it as part of our human narrative. This object doesn't belong to us, but by naming it, we weave it into our collective curiosity. Of course, not all names are glamorous. Some astronomers lament that our universe is filled with stunning, mysterious bodies that sound like printer errors. Imagine if the moons of Jupiter had been discovered today. They'd probably be called JUP 235 B47 instead of Europa. There's an art to naming that modern science sometimes forgets, though a few rebels try to keep the spark alive. For example, asteroid 486958 Arakoth, the faraway Kuiper Belt object visited by NASA's New Horizons probe, means sky in the Powhatan language, a respectful nod to indigenous culture and the heritage of human sky watching. 3IATLAS may not have a lyrical name, but it carries something more profound, a timestamp in our technological era. It's a reminder that humanity's tools have grown powerful enough to spot a pebble from another star system and give it an identity. The telescope that found it wasn't gazing at the sky for beauty. It was doing a job. But in doing so, it brought us face to face with something truly extraordinary. And that's the quiet beauty in this bureaucratic-sounding title. 3IATLAS isn't poetic, but it's honest. It tells the story of our progress. Third interstellar visitor, found by a machine named for a god who held the heavens. It's the mythology of science in shorthand. So, yes, it's a little sterile, a little official. But look deeper, and it's got heart. It's a name that bridges myth and math, poetry and programming. Because when you discover something that has traveled for millions of years through interstellar space, survived radiation, cold, and time itself, what else can you do but give it a name that says, "We saw you"? And in that moment of naming, humanity once again carved its initials into the stars. Before 3IATLAS streaked across our skies, two other cosmic wanderers had already set the stage for this interstellar drama. Think of them as the first and second acts in a trilogy, the kind that leaves scientists equal parts thrilled, confused, and desperately in need of more coffee. Those earlier visitors, Oumuamua and Borisov, didn't just capture the world's imagination. They rewrote our understanding of what can drift between the stars. Each one arrived with its own personality. Oumuamua, the cryptic enigma, Borisov, the classic comet. And then came Atlas, waltzing in like it had read both their reviews and decided to be a little bit of both. Oumuamua's story begins in 2017 with the Pan-STARRS telescope, yes, another Hawaiian sky sentinel, spotting a small, fast-moving object cutting across our solar system at a bizarre angle. At first, astronomers thought it was just another asteroid, until its orbit revealed something jaw-dropping. It wasn't looping the sun. It was barreling straight through, on a hyperbolic path that could only mean one thing. It came from outside. Cue the collective gasp of the scientific community, followed by a global chorus of, "Wait, did we just find something from another star?" Now, Oumuamua didn't make things easy. It was tiny, barely 100 meters long, but reflected sunlight in a way that made it appear oddly elongated, like a cosmic cigar, or, depending on your level of imagination, a spaceship designed by a minimalist architect. It had no visible tail like a comet, yet it accelerated slightly as if gas jets were pushing it. Scientists tried to explain this non-gravitational acceleration with outgassing, volatile materials evaporating under sunlight. But there was no visible dust or vapor to prove it. It was like watching a magician pull off a trick while refusing to show the deck of cards. Naturally, the internet and a few scientists jumped straight to the fun conclusion. Maybe it was alien. Harvard astrophysicist Avi Loeb even suggested it could be an artificial probe, perhaps something like a light sail drifting through interstellar space. Most of the scientific community disagreed, leaning toward more natural explanations. But let's be honest. The idea that an alien artifact had casually cruised through our solar system gave everyone a delightful shiver. For a few months, Oumuamua wasn't just a rock, it was a celebrity. But as quickly as it appeared, it was gone. Oumuamua zipped past Earth at such speed that, by the time the debate was heating up, it was already fading from view. No spacecraft could catch it. No second look was possible. It left behind more questions than answers, an unsolved cosmic mystery with an oddly poetic name. In Hawaiian, Oumuamua means a messenger from afar arriving first. The name fit perfectly. The universe had just delivered its first interstellar postcard, and it was written in riddles. Then, in 2019, before the dust of speculation had settled, another visitor arrived, 2I Borisov. This one was a relief to astronomers everywhere, because at last it behaved. Discovered by amateur astronomer Gennady Borisov from his backyard observatory in Crimea, it turned out to be a proper comet. Icy, dusty, and sporting a tail like a classic textbook illustration. For the first time, we could study a piece of another star system and actually understand what we were looking at. Borisov's composition looked strikingly similar to comets from our own solar system, containing familiar compounds like water ice, carbon monoxide, and cyanide gas. That discovery was oddly comforting. It suggested that other star systems form their comets with the same basic ingredients as ours. In other words, our solar system wasn't the cosmic weirdo we sometimes feared it might be. The chemistry of creation, it seemed, was universal. While Oumuamua had been a riddle, Borisov was a revelation. We could observe it for months, track its path, and study its spectrum. It was like finally getting a proper interview after years of chasing blurry paparazzi photos. Astronomers used every major telescope they could, Hubble, ALMA, Gemini, to analyze its light and determine its makeup. The results painted a picture of a comet that likely formed in a cold, distant region of another solar system. Perhaps one that experienced violent planetary migrations that flung icy bodies into interstellar space. The contrast between the two objects couldn't have been sharper. Oumuamua was dry, rocky, and puzzlingly fast. Borisov was wet, dusty, and wonderfully cooperative. If Oumuamua was the mysterious stranger in a trench coat who spoke in riddles, Borisov was the chatty traveler who happily shared family recipes from another star system. Between the two, astronomers began to realize just how diverse interstellar visitors could be. And that's where 3IATLAS entered the scene years later. It was as if the universe had been listening and decided to up the ante. Oumuamua had made everyone speculate. Borisov had made everyone analyze. And Atlas arrived saying, "I'll do both, thanks." It looked comet-like, but behaved unpredictably, brightening and fading in ways that defied expectations. It seemed fragile, unstable, even self-destructive as it approached the sun, almost as though it were torn between being a comet and something else entirely. What these three objects collectively taught us is that interstellar travelers aren't a one-size-fits-all category. Each one carries a distinct story from its home system. Oumuamua may have been a fragment of a larger body torn apart long ago. Borisov might have been a pristine comet ejected from a forming planetary nursery. And 3IATLAS, well, it could be the messy middle ground, a bridge between the two, showing us how fragile and complex these cosmic migrants can be. Their combined lessons are profound. First, interstellar objects are probably far more common than we thought. The fact that we've found 3 in just a handful of years suggests they're zipping through the solar system all the time. We just lacked the technology to notice. Second, each one offers a snapshot of another solar system's history, frozen in its material. Studying them is like finding alien fossils drifting through space. And third, they remind us that the universe is not a tidy place. It's dynamic, chaotic, and full of surprises that don't fit into neat scientific categories. But perhaps the most human lesson of all is that discovery never stops being thrilling. Oumuamua reminded us how it feels to be utterly baffled. Borisov reassured us that even the alien can feel familiar. And Atlas, it reminded us that the story is just getting started. 3 visitors, 3 mysteries, 1 growing sense of cosmic community. Somewhere out there, pieces of other worlds are still traveling through the galaxy, silent and patient, waiting for their moment to be seen. And when the next one comes, and it will, you can bet we'll be ready. Telescopes humming, coffee brewing, and astronomers whispering to themselves, "All right, what have we got this time?" If 3IATLAS were a person, it would be that mysterious traveler who arrives in town wrapped in a tattered cloak, leaving everyone whispering, "Where did they come from? And what's under that hood?" Unlike most cosmic guests, 3IATLAS didn't stay long enough for small talk, but it left behind enough clues for scientists to play cosmic detective. And make no mistake, astronomers love a mystery. The first thing everyone wanted to know was simple. What is this thing actually made of? Is it a comet? An asteroid? A fragment of something that exploded 1 billion years ago? The short answer, probably a comet, but a comet with commitment issues. When 3IATLAS was first spotted, it had all the hallmarks of a comet. It brightened as it got closer to the sun, suggesting volatile materials like water ice or carbon monoxide were heating up and turning into gas. That's classic comet behavior. But then, it began to dim again far too early. The light curve, the graph that tracks an object's brightness over time, showed strange fluctuations. It wasn't steady. It wasn't predictable. It was In scientific terms, doing weird stuff. For astronomers, those flickers of brightness are gold. They're not just pretty lights, they're fingerprints. Or rather, the closest thing to fingerprints you can get when your suspect is a rock millions of kilometers away. As one researcher joked, space detectives don't get fingerprints. They get light curves, basically the mood swings of a rock millions of kilometers away. By measuring how that light changed over time, astronomers could infer things about its shape, spin, and even composition. When sunlight hits an object in space, some of it reflects back depending on what the surface is made of. Rock, ice, metal. Each leaves a slightly different spectral signature, like a cosmic barcode. Scientists break this light down into its component wavelengths, using a technique called spectroscopy, which is really just a fancy way of saying, split the light and see what it's hiding. Through those spectral clues, researchers began piecing together 3IATLAS's chemical makeup. It appeared to contain volatile ices, the same sort of frozen materials found in our solar system's comets. Substances like carbon dioxide, methane, and ammonia, likely made up part of its interior, trapped since the dawn of whatever star system it came from. But something was off. Its outer layers seemed unusually fragile, as if loosely glued together rather than compacted by billions of years of cosmic collisions. And then came the real drama, the breakup. As 3IATLAS approached the sun, it began to disintegrate. Its brightness surged, then dropped, then fractured into multiple smaller pieces. It was like watching a slow-motion explosion, not violent, but inevitable. The heat and gravitational stress from the sun was simply too much for it. This wasn't a well-built rock. It was a fragile bundle of frozen dust and dreams, held together by the celestial equivalent of duct tape. Why does this matter? Because the way an interstellar object breaks apart tells scientists what it was made of and how it was formed. A tightly bound metallic asteroid would survive the sun's pull with ease. A fluffy, ice-rich comet, on the other hand, would crumble like a snowball tossed into a campfire. 3IATLAS fell firmly into the latter category, an interstellar snowball that had been wandering through the galaxy for who knows how long before our sun melted it down to its secrets. One of the most intriguing things about the breakup was the debris it left behind. By tracking how the fragments scattered, scientists could estimate how strong or weak the original object was. Spoiler, not very. It likely had the structural integrity of a stale croissant. And that's fascinating, because it suggests 3IATLAS hadn't spent much time bumping into other objects in space. It might have been drifting quietly in interstellar space for eons, untouched, unaltered, a pristine relic of its home system's early days. Spectral data also hinted that 3IATLAS was rich in carbon-based materials. That's exciting for one big reason. Carbon chemistry is the building block of life as we know it. No one's saying this thing was hauling alien microbes across the stars. But it's a reminder that the raw ingredients for life are everywhere. If a fragment of another star system can carry the same essential compounds we find in our own comets, it means the galaxy might be cooking from the same recipe. There's also something deeply poetic about how scientists decode all this. They don't touch the object. They don't sample it. They just watch how light bounces off it and fades. The tiniest flicker can reveal if it's spinning, tumbling, or cracking apart. Every data point is a breadcrumb in the void. And when they line those breadcrumbs up, an astonishing story emerges, one of ice and dust, of formation and destruction, of a lonely wanderer from another world disintegrating under the light of an unfamiliar sun. But there's another layer of fascination here. The way 3IATLAS fell apart might tell us something about its home. The fragility of its material hints that it may have formed far from its star, in the frigid outer regions where ices accumulate like cosmic frosting. That means the system it came from likely had gas giants, just like ours, capable of flinging icy comets outward into the interstellar dark. Every crumb of its disintegrated body is a clue about another solar system's architecture. Of course, while scientists were methodically running their analyses, the rest of us couldn't help but marvel at the irony. Here was a traveler that had survived interstellar space, endless radiation, gravitational tides, cosmic dust storms, only to crumble the moment it came near our sun. It's almost as if it saw the spotlight and panicked. And yet, that demise gave us the answers we needed. The disintegration of 3IATLAS wasn't the end of its story. It was the revelation. In dying, it told us what it was made of, where it might have come from, and just how fragile the cosmic messengers between stars really are. When the last of its fragments faded from our instruments, astronomers weren't disappointed. They were exhilarated. Because what 3IATLAS gave us wasn't just a puzzle solved. It was a reminder that even in its brief, self-destructive visit, it managed to whisper the story of another world across the cosmic void. A little dusty, a little unstable, and absolutely unforgettable. The anatomy of a true wanderer. By the time 3IATLAS started falling apart, astronomers had already suspected it was fragile. But even they didn't expect such a dramatic exit. This interstellar traveler had crossed the black gulfs between stars, drifting untouched for possibly millions of years, only to crumble the moment it got too close to our sun. If space had a sense of irony, this would have been it. The first signs of trouble came in the data. Observers tracking 3IATLAS noticed that its brightness was changing in ways that didn't make sense. Normally, as a comet approaches the sun, it brightens steadily. Ice begins to vaporize. Gas jets erupt from its surface, and sunlight reflects off the expanding cloud of dust. But 3IATLAS didn't follow the rules. Its glow flickered erratically, like a campfire about to go out. Then came the fade, a sudden drop in brightness that meant one thing: the comet was breaking apart. Now, comets disintegrating near the sun isn't unusual. In fact, it's practically a cosmic tradition. These icy bodies are fragile by nature, loosely bound lumps of dust, rock, and frozen gases, often described as dirty snowballs. They formed in the outer reaches of star systems, where cold temperatures allowed volatile materials to freeze solid. But when they venture inward toward a star, the heat wakes up those volatile compounds in spectacular fashion. Imagine an ancient ice cube hurtling toward a blowtorch. As sunlight pours in, frozen gases inside the comet begin to sublimate, turning straight from solid to vapor. The pressure builds up under the surface, forming jets of gas that shoot into space. This process, called outgassing, is both beautiful and destructive. Each jet acts like a miniature rocket engine, pushing the comet in unpredictable directions and spinning it faster and faster. If those forces get too strong, the comet literally tears itself apart. In the case of 3IATLAS, the outgassing was ferocious. It wasn't used to this kind of heat. After all, its home star, wherever that was, might have been cooler, dimmer, or farther away. Our sun, by comparison, was an uninvited sauna session. The closer Atlas got, the more its icy core began to vaporize, until the stress overwhelmed its fragile body. One astronomer quipped, "The sun basically looked at 3IATLAS and said, 'You can't handle this level of drama,' and it couldn't." But while its destruction was inevitable, it was also incredibly valuable. Breakups like this are like autopsies in real time. Scientists can study how the pieces separate, how fast they move, and what kind of material gets exposed. Every fragment carries clues about the comet's structure and composition, offering a glimpse beneath the dusty crust into the pristine layers below. For an interstellar object, that's priceless data. When 3IATLAS began splitting, telescopes from around the world and in orbit scrambled to record the process. Hubble turned its gaze toward the fading comet and captured images showing it had fractured into several distinct pieces, each trailing its own faint tail. By measuring the relative brightness of these fragments, astronomers could estimate their size, some no bigger than city blocks. The pattern of breakup suggested that the comet's nucleus wasn't solid, but a fragile agglomeration of loosely packed chunks, more like a pile of cosmic snow than a solid rock. The breakup also gave researchers a rare look at the internal cohesion, or lack thereof, of an interstellar object. Unlike asteroids, which can be solid chunks of metal or stone, comets are porous and fluffy. They contain voids and cracks filled with ices that expand and contract as temperatures change. Over millions of years of interstellar travel, those ices may have fractured even more, making 3IATLAS a ticking time bomb of stress and weakness. Once it met the sun's warmth, it simply couldn't hold itself together. Another culprit in its demise was likely rotational spin-up. As jets of gas shot off its surface, they acted like thrusters, slowly changing its spin rate. It's the same principle that makes a figure skater spin faster when pulling in their arms. Except, in this case, the skater exploded. If the spin becomes too fast, centrifugal forces tear the object apart, especially if it's already cracked and fragile. For 3IATLAS, that seemed to be the final straw. Even as it disintegrated, the data it provided was astonishing. Scientists observed that the composition of its dust and gas suggested similarities to comets formed in our own solar system, particularly in their icy chemistry. That was a revelation. It implied that star systems across the galaxy might share common ingredients, that the recipe for building comets, and perhaps even planets, follows the same cosmic cookbook. As tragic as its demise seemed, it was a gift to science. By watching how it broke apart, astronomers could refine their models for how interstellar comets behave near stars, which helps us prepare for the next time one drops by. Each breakup tells us how much sunlight these travelers can handle, how their materials respond to heat, and how fragile their structures really are. It's the kind of data that no lab experiment can replicate. There's also something poetic in the spectacle of destruction. When 3IATLAS shattered, its fragments reflected sunlight in a sparkling arc, briefly forming a misty tail before fading away. It was a cosmic fireworks show, one final flare of brilliance before it vanished into space forever. To some, that might sound like tragedy. To astronomers, it was beauty. A dying comet turning its own breakup into a burst of knowledge. And while its pieces scattered into oblivion, the information it left behind stayed with us. We learned how fragile interstellar comets can be, how they react to unfamiliar heat, and how their deaths can reveal more than their lives ever could. 3IATLAS didn't survive its encounter with the sun, but, in a way, it didn't need to. It came, it dazzled, and it disintegrated, leaving behind data, insight, and a reminder that even in the cold logic of physics, there's room for drama. Because in the grand story of astronomy, not every hero makes it out intact. Some burn bright, fall apart, and in doing so, illuminate the universe a little more for the rest of us. When 3IATLAS finally gave up the ghost and crumbled into cosmic confetti, astronomers didn't mourn. They got to work. Because in space, even the dust of destruction tells a story. Every particle that drifted away from that shattered interstellar comet was a piece of alien evidence, a microscopic relic from a solar system that formed under a completely different sun. To scientists, that dust was gold dust, ancient extrasolar breadcrumbs scattered across the void. If there's one thing astronomers have learned, it's that when a comet falls apart, it stops being an object and starts being an archive. The dust, gas, and ice it releases carry information about what it was made of, how it formed, and what kind of environment it once knew. 3IATLAS might have disintegrated spectacularly, but in its dusty remains lay the story of another world. As one researcher wryly put it, every bit of dust from 3IATLAS is a postcard from another star system, just with terrible handwriting. To read those postcards, scientists turn to a powerful set of tools. When sunlight hits dust grains, It scatters and reflects light in very specific ways. By splitting that light into its spectrum, a rainbow fingerprint, astronomers can see which chemical elements and molecules are present. Silicon, carbon, iron, water, methane, ammonia, each has its own spectral signature. A little tick mark in the rainbow that says, "I was here." Even the tiniest grain carries chemical secrets billions of years old. What made the dust from 3IATLAS so intriguing was its spectral resemblance to comets from our own solar system, but with a few peculiar differences. For one, it seemed to contain an unusually high ratio of carbon-rich compounds, possibly complex organic molecules that had formed in the cold outer regions of its home star's protoplanetary disk. That was thrilling because it suggested something universal. The same chemistry that built our comets might be happening all across the galaxy. The seeds of planets, and maybe life itself, aren't unique to our sun. They're a shared inheritance of stardust. Another clue came from the dust's reflectivity. When sunlight hit the debris cloud of 3IATLAS, it scattered light in a pattern that implied fine, fluffy particles rather than compact grains. That tells scientists something crucial about its history. This material hadn't been heavily processed or compacted by collisions or heat. It was primitive, raw material from the dawn of another solar system. It's like finding an ancient relic, perfectly preserved in ice, untouched by time. But studying interstellar dust isn't just about chemistry. It's about architecture. Each tiny grain is a clue to how planets form. In our solar system, dust coalesced into pebbles, then rocks, then worlds. If 3IATLAS's dust has similar properties, it suggests that other star systems go through the same process, spinning disks of gas and dust, gradually giving birth to planets through the same slow, sticky magic. By studying the structure of that dust, astronomers can test theories about how common Earth-like worlds might be across the galaxy. And there's something delightfully absurd about how this detective work happens. Scientists on Earth, sitting in observatories and labs, are analyzing the chemistry of dust that originated around a star, possibly hundreds of light years away. Dust that traveled through interstellar space for eons, dodged radiation and cosmic rays, and then briefly passed through our solar system before fading into darkness again. It's like finding a bottle washed up on a beach and realizing it came from an entirely different continent, and then managing to read the faded letter inside. Of course, no one could actually collect a sample from 3IATLAS's debris. It was too far, too fast, too fleeting. But the beauty of modern astronomy is that light itself is enough. Light carries all the information needed to decode the story. The color of the dust cloud, the way it fades, the way it polarizes sunlight. It all becomes part of a language scientists have learned to read fluently. One of the most surprising things about 3IATLAS's dust was its apparent similarity to early solar system comets. That may sound mundane. Oh, It's made of the same stuff we are. But that's exactly what makes it profound. It means the universe doesn't play favorites. The same ingredients that made our world, our oceans, and perhaps even our biology seem to be scattered everywhere. Hydrogen, carbon, oxygen, the usual suspects in the cosmic pantry, appear to be universal. 3IATLAS was proof that the chemistry of creation is a shared language written across the stars. And yet, there were subtle differences too, hints that its home system may have formed in slightly different conditions. Perhaps its star was cooler, its protoplanetary disk richer in carbon, or its comets born farther from the heat. Those differences matter. They help refine models of planetary formation, showing how small environmental changes can lead to big variations in the worlds that emerge. Maybe its home system produced more icy bodies, fewer rocky planets, or strange hybrid objects that blur the lines between comet and asteroid. Every dust grain from 3IATLAS whispered hints of those possibilities. But the real magic of the dust was philosophical. It reminded us that our solar system isn't an isolated miracle. It's part of a galactic community. We're made of the same elements that drift between stars, that fall into newborn suns, that gather into planets and people. The dust from 3IATLAS was a piece of that cosmic web, a literal connection between here and somewhere unimaginably far away. Even as it faded, that dust lingered briefly in our sky, scattering sunlight into faint, ghostly trails. For astronomers, those trails weren't just beautiful. They were data, history, and poetry all at once. Each grain was a fragment of a distant story, written long before Earth existed. And that's the marvel of it. A single comet's death revealed not just what it was made of, but what everything might be made of. The blueprint of worlds beyond our reach. So yes, 3IATLAS disintegrated spectacularly. But its dust didn't vanish in vain. It told us that the universe builds its creations from the same handful of humble ingredients, scattering them like breadcrumbs from star to star. And somewhere, drifting through the void, a few last grains of that interstellar traveler are still out there, silent, ancient postcards from another sun, waiting for someone, someday, to read their terrible handwriting. The universe is often imagined as a vast, lonely place. Endless black stretches between distant stars. Each solar system an isolated island of light, adrift in a cosmic ocean. But every so often, an object like 3IATLAS comes along to remind us that this ocean isn't empty. It's full of travelers, messengers, and drifters carrying the raw materials of worlds from one star to another. What looks like separation is actually connection. What feels like stillness is constant exchange. Because while we've only recently begun spotting these interstellar visitors, the galaxy has been running a quiet courier service for billions of years. Dust, ice, and rock are constantly being traded between star systems. It's not a new phenomenon, it's an ancient one. As one astronomer put it with a smirk, The galaxy's been doing material shipping long before Amazon Prime thought of it. The process starts simply enough. Imagine a young star surrounded by a swirling disk of gas and dust, the birthplace of planets. In these crowded nurseries, gravity is both a sculptor and a troublemaker. Planets form, moons coalesce, and comets take shape in the cold outer regions. But every once in a while, a giant planet or a close encounter flings one of those icy bodies out of the system entirely. It's cosmic billiards on a grand scale. One gravitational nudge, and suddenly, a comet that once circled its star for eons is catapulted into interstellar space, beginning a journey that could last longer than the existence of its home world. Over billions of years, trillions of such fragments have been ejected from countless systems. They drift silently through the galactic void, carrying the elemental fingerprints of their origins. Some pass through other systems, like ours, briefly warming as they skim past alien suns before heading off again. Every one of them is a capsule of chemistry, a tiny ambassador from a world we'll never see. When 3IATLAS blazed through our skies, it wasn't just a visitor. It was part of this vast interstellar exchange, the Milky Way's version of cultural diffusion, only with comets instead of cuisine. Its dust and ice carried the isotopic ratios, mineral patterns, and molecular compounds of a distant birthplace. When it broke apart and scattered particles across our solar neighborhood, it quite literally added a few atoms from another star system to our own. The galaxy is a recycler, endlessly mixing, matching, and reusing its ingredients to build new worlds. That idea that star systems can share material isn't just poetic, it's revolutionary. It suggests that the building blocks of planets, and even life, might not be confined to one origin. When scientists study meteorites and comets within our solar system, they often find amino acids and other organic molecules, the chemistry that can lead to life if given the right environment. Now, imagine those same molecules hitching rides across the galaxy, stowed away on icy comets like interstellar stowaways. This is where the theory of panspermia enters the picture. The idea that life, or at least its precursors, could spread from one planet to another, or even one star system to another, through natural cosmic processes. No alien intervention required, just time, motion, and a little bit of cosmic luck. A chunk of rock blasted off a living world by an impact could drift for millions of years before landing on another habitable planet. Most such fragments would perish in the void, but it only takes one to seed a new beginning. If that sounds far-fetched, consider this. We found meteorites from Mars here on Earth. Real, tangible pieces of another planet that crossed the interplanetary gulf and survived the plunge through our atmosphere. If it can happen between two worlds in the same solar system, the idea that it could happen on a galactic scale doesn't sound so absurd. 3IATLAS might not have carried life, but it could easily have carried the same raw ingredients from which life emerges. Carbon compounds, frozen water, Simple organics, the DNA alphabet of the cosmos, scattered like confetti across the stars. And that means when we look up at the night sky, we might not just be seeing other stars. We might be seeing places we're already connected to at the molecular level. Maybe some of the atoms in your body once drifted through another solar system, part of an ancient interstellar traveler long before Earth existed. After all, the atoms that make up everything, carbon, oxygen, iron, were forged in the hearts of long-dead stars and spread through the galaxy in supernovae. The galaxy has been sharing for a very long time. We're just starting to notice the couriers. These connections reframe how we think about isolation in the cosmos. We tend to imagine each star as a solitary beacon. But the truth is, they're part of a galactic network, exchanging dust, comets, and perhaps even the spark of biology itself. Interstellar objects like 3IATLAS are the physical proof of that network. They are the galaxy's mail carriers, drifting endlessly, carrying messages not in words, but in chemistry. From a human perspective, this is both humbling and exhilarating. It means we're part of something much larger than our little solar cul-de-sac. Our atoms, our oceans, maybe even our life, could owe their existence to materials shipped in from another corner of the galaxy. And in turn, fragments from our system may one day drift through the skies of another world, leaving scientists there wondering about us. Picture it, an alien astronomer on a distant planet, someday pointing a telescope at a faint, fast-moving speck of light. They run the number, calculate the orbit, and realize it's not from around here. Maybe they name it after their own telescopes. Maybe they marvel at its strange chemistry. Maybe, just maybe, they say, this one's from that small yellow star across the spiral arm. And so, the story continues. The galaxy doesn't just contain countless stars. It contains relationships, a constant give and take of material and meaning. Every interstellar object, from Oumuamua to Borisov to ATLAS, is a reminder that the Milky Way is not a cold, lonely place. It's a living ecosystem of exchange. 3IATLAS wasn't just a visitor. It was a reunion guest, bearing cosmic gifts from another branch of our galactic family. And as its fragments spread across space, they joined the grand circulation that's been happening since before the first planet cooled. In the end, maybe the galaxy isn't a collection of separate stories at all. Maybe it's one enormous, ongoing narrative, written in dust, ice, and rock, constantly edited by the hands of passing comets. And if that's true, then 3IATLAS was just the latest delivery in a saga billions of years in the making. A reminder that even across the vastness of space, we're all sharing the same cosmic address. When Oumuamua first blazed across our skies in 2017, astronomers treated it like a once-in-a-lifetime event, the cosmic equivalent of spotting a unicorn strolling through Times Square. Then came Borisov. Then 3IATLAS. 3 interstellar visitors in just a few years? Suddenly, the unicorns were showing up in herds. The natural question followed. Were we just lucky, or have these galactic guests been dropping by all along while we weren't looking? The surprising answer? They've probably always been here. We just didn't notice. For most of human history, our telescopes were simply too narrow, too slow, or too few. We were the distracted neighbors of the galaxy, living under a sky filled with visitors and never glancing up long enough to wave. As one astronomer joked, "Turns out the universe has been dropping by for eons. We just never looked up from our cosmic phones." Let's put this into perspective. Our solar system is massive, but it's not fenced in. It sits inside the galaxy like a house with the doors open, and interstellar space is the highway that runs past the front yard. Every day, countless particles of dust, gas, and maybe even the occasional pebble drift through. The larger visitors, objects like Oumuamua, Borisov, and 3IATLAS, are rarer, but not that rare. Statistically, hundreds of interstellar objects may pass within the orbit of Earth each year. Most are simply too small or too dim for us to spot. The problem has never been their scarcity. It's been our blindness. For centuries, even the best telescopes could only track relatively slow-moving, bright objects that lingered in the night sky for days or weeks. Interstellar travelers, on the other hand, are the cosmic speed demons, small, faint, and moving at tens of kilometers per second. By the time an old-fashioned astronomer might have noticed something strange about their orbit, the object was already halfway out of town. But technology has changed everything. The rise of automated wide-field survey systems, like Pan-STARRS, ATLAS, and the upcoming Vera C. Rubin Observatory, has turned the night sky into a constantly monitored stage. These observatories don't just stare at one patch of stars. They sweep across vast portions of the sky every night, detecting anything that moves, flashes, or fades. Each new image is compared to previous ones by sophisticated algorithms that can identify subtle differences a human eye would never catch. It's like going from checking your backyard with a flashlight to using a network of motion sensors that never sleep. That's why we're suddenly seeing more interstellar objects. The universe hasn't gotten busier, we've just gotten better at noticing. What once appeared miraculous now looks inevitable. With the new generation of telescopes, astronomers expect we'll start detecting interstellar visitors regularly, maybe even yearly. Some simulations suggest that at any given moment, there could be thousands of alien rocks drifting inside our solar system, quietly minding their own business. They're out there. We're just finally tuning in to the right cosmic frequency. And that realization is changing how scientists think about the galaxy. The fact that we've already caught 3 in such a short span implies that the Milky Way is teeming with debris from other systems. Every time a planet forms, collisions fling fragments outward. Every time a comet brushes too close to its home star, a piece breaks off and gets ejected into the void. Multiply that by the hundreds of billions of stars in our galaxy, and you get a Milky Way filled with wandering orphans, objects cast out of their birthplaces, now roaming freely through interstellar space. Astronomers are even starting to estimate their abundance. Based on what we've seen, there could be trillions of these interstellar wanderers in our galaxy alone. So many that, statistically speaking, our solar system should always have at least one or two drifting through it at any given time. Most are tiny, less than a few meters across, invisible to all but the most sensitive instruments. But a few, like 3IATLAS, are large enough to catch the sun's light and announce their presence. The realization that they might be common has huge implications. For one thing, it opens up the tantalizing idea that we could eventually intercept one. Future missions, like NASA's proposed Comet Interceptor, are being designed with precisely this goal in mind: to launch quickly toward any new interstellar object discovered, collecting data before it vanishes back into the dark. Imagine sending a spacecraft to rendezvous with a visitor from another star system, a literal meeting between worlds, not in science fiction, but in real life. But beyond the excitement of exploration, this shift in understanding also reframes our cosmic perspective. For centuries, we've imagined our solar system as a closed system, a tidy bubble where everything inside belongs to us. The truth is messier and more beautiful. The solar system is porous. Material flows in and out. Some of it stays, some of it passes through, and some of it leaves traces we'll never see. We are not a self-contained story. We're a paragraph in the galaxy's ongoing novel. It's humbling to think that interstellar visitors have probably brushed past Earth countless times before, long before telescopes, before civilization, even before humanity existed. Imagine a time 50 million years ago when a comet from another star streaked silently across the prehistoric sky, its tail glinting above dinosaurs or early mammals. No one saw it, no one recorded it, but it happened. The galaxy doesn't wait for observers. Now, though, we're finally catching up. Our technology has turned curiosity into vigilance. We're no longer staring at the stars in ignorance. We're reading the fine print of their motion. Every new detection adds a data point, another glimpse into the invisible web of debris, linking all star systems together. And the best part? This is just the beginning. The Vera C. Rubin Observatory, set to begin its all-sky survey soon, will be able to detect objects hundreds of times fainter than anything we can see today. Astronomers predict it will uncover dozens, perhaps hundreds, of interstellar visitors over its lifetime. Some will be small, fleeting, unremarkable, but among them could be one that changes everything. A perfectly preserved messenger from another sun, caught just in time. So no, these cosmic travelers aren't rare. We just had our heads down for too long. The universe has always been passing through our neighborhood, dropping by, saying hello, and leaving faint streaks of light as calling cards. Now that we're finally paying attention, the only question left is, who's next? Long before 3IATLAS streaked across our telescopes, astronomy was a field ruled by patience. Ancient stargazers spent hours sketching constellations. Renaissance astronomers squinted through brass tubes. And even a century ago, discovering a comet often meant staying up all night, staring at photographic plates until your eyes went on strike. But today, the machines do the watching for us, tirelessly, methodically, obsessively. If the universe ever blinks, a telescope somewhere will notice. Welcome to the age of the automated sky. The discovery of 3IATLAS wasn't just a lucky break. It was the result of technology evolving faster than our own ability to drink enough coffee to keep up with it. The telescopes that found it, like ATLAS and Pan-STARRS, are part of a new generation of robotic observers that never sleep. They sweep the heavens every night, capturing millions of gigabytes of data, scanning for anything that dares to move, flash, or flicker. Modern telescopes are basically night owls with photographic memory and no social life, the perfect scientists. Take Pan-STARRS, for example, short for Panoramic Survey Telescope and Rapid Response System. It sits atop Haleakala in Hawaii, 10,000 feet above sea level, watching the sky with a pair of massive digital eyes. Each of those eyes, really each telescope, is equipped with one of the world's largest digital cameras, capable of capturing a region of sky so wide it could fit 60 full moons at once. Every night, Pan-STARRS scans the heavens and compares new images with its vast archive of older ones. Anything that shifts position, an asteroid, a comet, a supernova, or an interstellar intruder, gets flagged within minutes. That's how Oumuamua was found in 2017. The system's software spotted something moving too fast and too oddly to be local. Within hours, the alert had spread through the global astronomy network, triggering telescopes on every continent to join in. What once took months of verification now happens automatically. Data moves faster than the objects themselves. Then there's ATLAS, the Asteroid Terrestrial Impact Last Alert System, the same network that later discovered 3IATLAS. It operates more like an early warning radar for the sky, scanning every inch of visible space several times a night to detect objects that might pose a threat to Earth. Each ATLAS telescope takes 1,000 wide-field exposures per night, and the software compares them in real time, hunting for any moving points of light. Its job is to catch anything on a collision course with us before we have to start designing panic shelters. But ATLAS has proven itself more than a sentry. In 2020, it caught something that wasn't coming at us, but through us. The third interstellar object, 3IATLAS. It was a moment of technological serendipity, a system designed to protect Earth from cosmic impacts, instead ended up expanding humanity's view of the galaxy. It's like installing a burglar alarm and discovering you've accidentally found a portal to another dimension. Together, these telescopes represent the dawn of a new era, one where machines do the watching and humans do the wondering. The sheer amount of data they collect is staggering. In a single night, Pan-STARRS alone generates more information than astronomers gathered in centuries of pre-digital sky watching. That data is sifted by artificial intelligence, trained to recognize subtle patterns, the kind that would slip past human observers but scream, "Something's weird here," to an algorithm. And yet, we're still just getting started. The upcoming Vera C. Rubin Observatory, currently being built in Chile, is about to take this game to another level. When it begins operations, it will conduct what's called the Legacy Survey of Space and Time, a 10-year project that will photograph the entire visible sky every few nights, producing an astronomical movie of unprecedented depth and scale. Imagine flipping through billions of time-lapse images of the universe, frame by frame, watching galaxies evolve, stars explode, and unknown objects drift across the void. The Rubin Observatory's camera will be a monster, 3.2 billion pixels strong, the largest ever built for astronomy. If you try to view one of its full-resolution images on a normal monitor, you'd need 400 ultra-high-definition TVs tiled together. Each exposure will capture an area of sky 7 times wider than the full moon. When it starts running, it's expected to detect tens of millions of moving objects, from asteroids to comets to the occasional rogue interstellar wanderer like 3IATLAS. For astronomers, Rubin will be like switching from reading the universe in snapshots to streaming it live in 8K resolution. It won't just find interstellar objects, it will catch them in the act. But what's truly transformative about these telescopes isn't just their size or precision, it's their memory. They don't forget. Every observation gets archived, cross-referenced, and analyzed. That means astronomers can go back in time, digitally speaking, and look for patterns or missed detections. It's already happened. After Oumuamua was discovered, scientists combed through old Pan-STARRS data and found faint traces of it in earlier images. The past, once lost to the night, can now be replayed, and the automation doesn't stop at discovery. Once an alert is issued, say a new comet or interstellar object, telescopes around the world automatically reposition to observe it, forming an impromptu global network of sky watchers. It's a cosmic relay team where the baton is made of photons and the runners are scattered across continents. This technological leap has changed astronomy from a solitary pursuit into a symphony of coordination. It's no longer about one person discovering a comet from their backyard, though that still happens. It's about global collaboration, where robotic eyes feed data into cloud servers, artificial intelligence scans for anomalies, and scientists everywhere tune in for the breaking news from the cosmos. It's easy to forget how recently this revolution began. A few decades ago, astronomers relied on photographic plates, manually inspecting them for specks of light. Now, telescopes can spot a rock the size of a house halfway across the solar system before lunch. The sky has become a living database, and every night, humanity uploads another terabyte of the universe. 3IATLAS's discovery wasn't an accident. It was the inevitable result of machines that don't blink. These robotic observers have given us something ancient stargazers could only dream of: a constant, unbroken vigil of the heavens. And somewhere out there, as we speak, another faint dot is crossing the frame, a traveler from the stars, waiting for a machine with no social life and a perfect memory to notice it. Imagine stepping into your backyard one morning and finding a half-melted baguette lying mysteriously in the grass. It's not yours. No one nearby bakes bread like that, and it clearly came from far away. You'd have questions, right? What kind of place did it come from? What recipe was used? Do the bakers there make everything this crusty? Now, replace baguette with comet. And congratulations, you're thinking exactly like an astronomer studying 3IATLAS. As one scientist quipped, "Imagine learning about France because a baguette landed in your backyard. That's what studying 3IATLAS feels like." Because that's essentially what this interstellar visitor was. A fragment from another solar system's kitchen, carrying with it the recipe of its home star's formation. And by analyzing it, even from afar, scientists got to peek into an alien world without ever leaving our own. When 3IATLAS was first detected, its behavior immediately hinted at an icy, volatile, rich nature. It brightened as it approached the sun, just like a comet from our own solar system would. That suggested it contained frozen materials that were vaporizing under heat, probably water, carbon dioxide, and methane ice. But the way it brightened was peculiar. Its luminosity didn't follow the predictable curve of an ordinary comet. It fluctuated irregularly, as if the object were crumbling, venting gas, and reshaping itself in real time. Those inconsistencies weren't just chaotic, they were clues. They told scientists that this was not a rocky asteroid, but a fragile, loosely bound collection of ices and dust, the kind that forms far from a star, where temperatures are low and sunlight is faint. That pointed to a home system rich in comets, possibly one that had a structure similar to our own, with icy bodies populating the outskirts beyond its planets. In our solar system, that region is the Oort cloud, a vast sphere of frozen debris left over from the dawn of planetary formation. If 3IATLAS came from a similar zone, it meant that other stars likely have their own comet reservoirs too. And that's a big deal. For decades, astronomers suspected that Oort clouds were common, but they had no proof. Now, here was a piece of evidence literally flying through our front yard, whispering, "Yes, my system had one too." But the story gets even more interesting when you consider how it got ejected. A comet doesn't just wander away from its star on a whim. It needs a push, usually a violent one. The most likely culprit? Gravitational chaos. In young planetary systems, giant planets often migrate, shifting their orbits like rowdy teenagers rearranging furniture. When these massive worlds move, their gravity flings smaller bodies outward, sometimes with enough force to escape the entire star system. That's probably what happened to 3IATLAS long ago. a gravitational slingshot that turned it into a galactic nomad. By modeling its trajectory and composition, astronomers could infer that its home system may have been a lively place, full of large planets and dynamic orbital dances. The mixture of ices it carried suggested it formed in a cold region, but its ejection implied interactions with something massive and energetic. In short, it came from a system that was both icy and chaotic, much like ours was in its early days. That's what makes interstellar visitors like this so valuable. They're not just space debris, they're time capsules. Each one contains frozen clues about the environment it was born in, the temperature, the chemistry, the dynamics. It's like a bottle tossed into the galactic sea during the birth of a star system, drifting for eons until it washes up on our shores. Spectral analyses of 3IATLAS's light showed hints of carbon compounds and complex organics, similar to those found in comets from our solar system. That's remarkable because it means that the chemical processes that lead to organic molecules, the building blocks of life, aren't limited to our neighborhood. Whatever star birthed Atlas, it was brewing the same chemistry that fills our own comets. Life, or at least the ingredients for it, may be written into the galaxy's default settings. But there was another surprise. 3IATLAS seemed to disintegrate unusually quickly as it neared the sun. That could mean it was made of particularly volatile materials, ices that vaporize at lower temperatures than the ones found in our comets. If that's true, its home system might orbit a cooler star, one that allowed such delicate compounds to survive. That would make its birthplace a more temperate, fragile environment, one where heat was rare and cold ruled. In other words, Atlas could have been born under a dimmer sun. By studying how its brightness changed and how fast it fell apart, scientists could also estimate its density, or rather, its lack of it. The numbers suggested a structure that was more porous than any comet we'd seen before, almost sponge-like. That kind of fragility tells us something profound. The material that built 3IATLAS had remained largely unaltered since its formation. It hadn't collided, compacted, or been reshaped. It was a pristine relic of its system's earliest days, a direct sample of its proto-planetary disk. And just like that, with a few weeks of observation and a handful of light curves, astronomers found themselves holding a mirror to another world's history. One small, dying comet managed to confirm decades of theoretical models about how planetary systems form and evolve. It proved that our story, the tale of dust becoming worlds, of chaos giving way to order, isn't unique. It's the galaxy's favorite story, told and retold around every star. 3IATLAS reminded us that planetary systems aren't built in isolation. They're variations on a theme. Whether it formed around a small, cool dwarf star or a sun much like ours, the patterns were familiar. Ice, dust, gravity, time. The same 4 ingredients, shuffled in infinite combinations. And that realization reframed the way we think about the universe. each interstellar visitor isn't just an oddity, it's a messenger. They carry confirmation that the physics and chemistry that built us are happening everywhere. Every distant comet is a sibling to our own. Every icy fragment, a whisper from another family of worlds. So, when that faint speck of light labeled 3IATLAS crossed our skies, it wasn't just passing through. It was delivering a message written in starlight, that we are not alone in the way we were made. And all of that, the story of a distant sun, a chaotic ejection, and a frozen past, came to us the same way you'd learn about France from a baguette that landed in your backyard. One object, one clue, rewriting everything we thought we knew about the places we can't yet see. It happens every time. A strange object from deep space streaks through our solar system, moving faster than anything we've seen before, behaving just oddly enough to make scientists scratch their heads. And before the equations even hit the whiteboard, someone somewhere is already typing. Could it be aliens? Every time something weird enters the solar system, someone somewhere yells aliens faster than a UFO meme loads. It's almost tradition at this point, the cosmic equivalent of shouting plot twist at the first sign of mystery. And when 3IATLAS arrived, the reaction followed the same familiar pattern. Within hours of its discovery, social media threads lit up with speculation. Was it another Oumuamua, that cigar-shaped enigma that had people wondering if it was an alien probe in disguise? Was this the sequel, the interstellar visitor that finally brought receipts? To be fair, the fascination isn't just the result of internet conspiracy culture. It's something older and deeper. Humanity has always had a soft spot for mystery, and for the idea that we might not be alone. When an object comes flying in from another star system, it scratches both itches at once. It's foreign, it's unexplainable, and it's literally not from here. That's practically an engraved invitation for our imaginations to go full sci-fi. The first interstellar visitor, Oumuamua, set the tone. It was small, strangely shaped, and accelerated slightly as it left the solar system. Not enough to defy physics, but just enough to make scientists tilt their heads. Theories flew. Maybe it was outgassing invisible ices. Maybe it was a fragment of a larger body. Or, if you were feeling adventurous, maybe it was an artificial object, a light sail perhaps, drifting through space as a message or relic from another civilization. That idea didn't come from fringe corners of the internet either. It was proposed, quite seriously, by respected astronomers like Harvard's Avi Loeb. So, when 3IATLAS showed up a few years later, it was destined to inherit Oumuamua's legacy of suspicion. After all, here was another interstellar visitor, another rare object from beyond the stars. And this one was breaking apart in dramatic fashion, like a Hollywood explosion scene. Cue the whispers. What if it's not natural? The speculation didn't last long, though. Scientists quickly determined that 3IATLAS behaved exactly like a comet. A very fragile one, granted, but nothing that defied the laws of physics. Its breakup followed predictable thermodynamic principles. The gases it released matched those of known cometary materials. In short, there was no need to summon extraterrestrial engineers to explain it. Nature had the blueprints. Still, the fascination lingered, and that, in itself, is fascinating. Because even when evidence rules out the extraordinary, the human mind doesn't quite let go of the idea. We want the universe to surprise us with intelligence. The thought that we're not the only beings capable of curiosity and creation is as comforting as it is thrilling. When we point our telescopes into the void, we're not just looking for rocks. We're looking for reflections of ourselves. And let's be honest, it's hard to blame anyone for being hopeful. The galaxy is enormous. Hundreds of billions of stars, each with their own planets, moons, and possibly oceans. Statistically, it feels almost impossible that we're the only ones here. Yet, despite all our searching, the silence has been deafening. No signals, no messages, no incontrovertible signs. Just the occasional interstellar rock that passes through, like a mysterious note without a signature. That's why objects like 3IATLAS stir up so much excitement. They're physical proof that material can travel between stars. If rocks can do it, maybe life can too. And if life can, then perhaps intelligence isn't confined to a single world. Each new interstellar visitor is a blank canvas on which we project our hopes, fears, and cosmic loneliness. But 3IATLAS, for all its drama, turned out to be entirely natural. A wanderer shaped by gravity, heat, and time, not by alien intention. Scientists studied its spectrum, its motion, its breakup, and found no anomalies that required an artificial explanation. No radio signals, no metallic reflections. No course corrections, just an object obeying the cold, predictable dance of physics. Yet, the persistence of the alien question reveals something about us. Science and storytelling have always been intertwined. For every telescope scanning the heavens, there's a mind behind it, asking not just how, but who. The alien hypothesis isn't a failure of reason. It's an expression of curiosity. It's the human instinct to fill silence with imagination. In fact, some astronomers argue that keeping an open mind, even about extraordinary possibilities, is part of good science. As Carl Sagan famously said, extraordinary claims require extraordinary evidence. That doesn't mean dismissing the strange. It means investigating it carefully, without letting the excitement cloud the data. In the case of 3IATLAS, the data spoke clearly. Natural origin, no radio chatter, just ice and dust obeying the sun's rules. Case closed, at least for now. But the next time an interstellar visitor appears, you can bet the same cycle will repeat. Discovery, confusion, wild theories, alien memes, then calm analysis, followed by a tidy conclusion that's either mundane or magnificent. It's practically the rhythm of cosmic news coverage at this point. And maybe that's okay. Maybe the alien question is less about the objects themselves and more about what they awaken in us. That restless desire to connect, to imagine, to find meaning in the great cosmic silence. Because every time we ask, could it be aliens? What we're really asking is, could we matter to someone else out there? So no, 3IATLAS wasn't a spacecraft, or a probe, or a galactic calling card. It was just a natural traveler, a fragment of another world, making a brief cameo in ours. But it did something that no alien technology could do better. It made humanity look up, wonder together, and remember that we're part of something vast enough to still hold surprises. And maybe, just maybe, the next rock that crosses our sky will bring something even more mysterious. Until then, we'll keep watching, keep imagining, and keep shouting aliens just a little too early. Because really, that's part of the fun of being human in a universe full of question marks. If the universe were a museum, then interstellar objects like 3IATLAS would be the traveling exhibits, rare, priceless artifacts that show up unannounced, stay for a short time, and then vanish forever. The catch? You only get one shot to study them before they disappear into the dark again. And from that challenge, a brand new scientific field has emerged. Interstellar archaeology, the study of material from other stars without ever leaving our solar system. It's archaeology, but instead of digging in dirt, we're waiting for rocks to throw themselves at us. That might sound like a punchline, but it's becoming a legitimate scientific discipline. Until recently, interstellar archaeology would have sounded like a poetic exaggeration. After all, how do you study alien worlds when the nearest one is light years away? But Oumuamua, Borisov, and 3IATLAS changed everything. They proved that the galaxy is constantly sending us messengers, physical samples of other solar systems flying right through our backyard. Instead of dreaming about distant missions to other stars, astronomers realized, why not study the visitors that come to us? Each interstellar object is a time capsule of its home system's history. Locked inside are clues about its chemistry, its formation, and the chaotic gravitational ballet that once ejected it. The challenge now is how to catch these fleeting guests before they slip away. Astronomers have started to take that challenge seriously. With improved sky surveys like Pan-STARRS, ATLAS, and soon the Vera C. Rubin Observatory, scientists expect to detect many more interstellar objects in the coming decades. The trick is reacting fast enough. These objects move at ridiculous speeds, 30 kilometers per second or more, and once they're gone for good. The solution? Don't wait. Be ready. That's the idea behind a new generation of rapid response missions being planned right now. The European Space Agency's Comet interceptor, for instance, is designed to sit in space like a patient fisherman, waiting for the next big catch. Once an interstellar object or a new comet is detected, heading toward the inner solar system, the spacecraft can launch from its waiting point and intercept it on the fly. Think of it as a cosmic ambush, a robotic investigator lying in wait for the galaxy's next courier delivery. If a truly pristine interstellar visitor is spotted early enough, such a mission could rendezvous with it, snap close-up images, and maybe even sample its gases and dust. That would be a scientific jackpot, the first physical sample of material from another star system. It's the ultimate dream of interstellar archaeology, holding in your hand something that was born under an alien sun. But this field isn't just about future spacecraft. It's also about rethinking how we study what already falls into our lap. In 2014, for instance, US military sensors detected a small meteor that entered Earth's atmosphere at incredible speed, so fast that it likely came from outside the solar system. Officially known as CNEOS 2014-0108, it exploded over the Pacific Ocean, scattering tiny fragments into the sea. Years later, scientists began searching for remnants, hoping to retrieve and analyze the first confirmed interstellar meteor. Whether or not they find it, the concept is bold. Actual interstellar archaeology, with ocean dredging instead of telescopes. These projects mark a shift in how we view our cosmic neighborhood. For centuries, humanity has dreamed of visiting other star systems, sending ships across light years to collect samples and stories. But the new reality is far more practical and just as thrilling. Other star systems are visiting us. They're sending us debris, dust, and comets that carry the fingerprints of alien worlds. We just have to be smart enough to notice and quick enough to respond. And there's a philosophical elegance to this approach. It turns the vastness of space from an obstacle into an opportunity. Instead of chasing the unreachable, we're studying what the galaxy naturally provides. Every interstellar object that enters our system is like a free delivery of cosmic data. No warp drives required. The growing enthusiasm for interstellar archaeology also shows how science thrives on serendipity. Oumuamua's discovery wasn't planned. Borisov's wasn't predicted. 3IATLAS wasn't scheduled. Each was a cosmic accident that forced us to rethink what was possible. Now, we're trying to turn those accidents into anticipation. Astronomers are developing early warning systems, rapid simulation tools, and orbital response plans so that the next time a visitor arrives, we can meet it properly. Instruments ready, probes fueled, scientists wide awake. And the implications go far beyond curiosity. If we can intercept and sample an interstellar object, we can compare its isotopic ratios, mineral content, and organic chemistry to our own solar system's materials. That comparison could reveal whether the ingredients for life are universal or rare, whether other worlds form under similar conditions, and how often the galaxy's recipes repeat themselves. It's cosmic forensics on a galactic scale, a way to piece together the family tree of planetary systems without ever leaving home. Of course, it won't be easy. Interstellar objects are fast, faint, and unpredictable. The next one could arrive tomorrow or a decade from now. Missions like Comet Interceptor will have to be patient, sitting quietly in the outer solar system, like hunters at the edge of a clearing, waiting for movement. But the reward is worth it. A chance to hold a piece of another world, to touch something that was born under a different sun, perhaps before Earth itself existed. And that's the wonder of this new science. For all our technological ambition, our rovers, our satellites, our telescopes, the galaxy still manages to surprise us by doing the delivery work itself. We don't need to travel light years to learn about alien systems. The universe is already mailing us the evidence. Interstellar archaeology is young, but it's growing fast. It's a field built on patience, curiosity, and a touch of cosmic luck. Somewhere out there, drifting silently through the dark, the next messenger is already on its way. A shard of another star's story, heading toward our waiting instruments. All we have to do is keep our eyes open, our probes ready, and our sense of wonder intact. Because the next rock to throw itself at us might just carry the blueprints of another solar system. And maybe, just maybe, the first chapter of another world's history. When 3IATLAS finally faded into the dark, leaving behind only fragments and data, there was a collective pause, that rare, quiet kind of wonder that happens when humanity realizes it's just learned something profound about its place in the cosmos. Not a discovery of aliens or new planet, but something subtler, deeper. 3IATLAS reminded us that the universe isn't as distant as we once believed. The stars may be light years apart, but their stories, their dust, their chemistry, their echoes, are constantly crossing paths. For centuries, we thought of space as an expanse that separated. Each star was a lonely firefly, each solar system a sealed vault. But 3IATLAS and its fellow wanderers before it have turned that old picture inside out. The galaxy isn't a collection of isolated bubbles. It's a web of motion and exchange, a network of cosmic highways where matter, energy, and history circulate endlessly. The universe, it turns out, doesn't stay politely in its own lane. It mingles. That realization makes the cosmos feel suddenly smaller, not in size, but in intimacy. We now know that chunks of alien worlds are literally passing through our skies. Dust from other suns drifts into our atmosphere. Tiny particles forged in distant systems are mixing with our own interplanetary debris. We are breathing, touching, and orbiting in a sea of shared stardust. The boundaries between us and them, between here and out there, are far blurrier than we ever imagined. 3IATLAS wasn't just another rock. It was a messenger, a frozen relic that had traveled for millions of years, maybe billions, before briefly brushing past our sun. It came from an unknown star, long ago and far away, carrying the chemical memory of its birthplace. When it passed through our neighborhood, it became a bridge, a physical link between two star systems separated by unimaginable distance. For a brief moment, our solar system wasn't just our own. It was part of a galactic conversation that's been going on since the dawn of time. That conversation has always been there. We just weren't listening. The atoms that make up your body were once scattered across the galaxy in ancient supernovae. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it forged in stars that lived, died, and exploded long before the sun was born. Every atom on Earth has traveled across the cosmos, recycled and reassembled countless times. In a very literal sense, we are already interstellar. But what 3IATLAS did was make that truth tangible. For the first time, we could see the process happening, the exchange of matter between systems, the flow of cosmic ingredients from one corner of the galaxy to another. It's one thing to say, we're made of stardust. It's another to watch that stardust drift past your telescope. In its short visit, 3IATLAS managed to erase the idea of cosmic isolation. It told us that what happens around other stars doesn't stay there. When a planet forms in one system, some of its building blocks may eventually end up in another. When a comet melts near an alien sun, its fragments may wander until they brush past ours. The galaxy isn't a cold expanse of emptiness. It's an ecosystem, alive with exchange. And maybe, just maybe, it's not just materials that travel, maybe ideas too. When we study these interstellar visitors, we're not just learning about them. We're learning about ourselves. We're reminded that the universe doesn't revolve around humanity's curiosity. It's been busy long before we arrived. 3IATLAS didn't need us to make its journey meaningful, but by passing through, it gave us the chance to glimpse something larger than our species, our sun, or even our imagination. There's a humility in that, but also comfort. Because it means that our small corner of the Milky Way isn't cut off from the rest. It's connected by invisible threads of matter and motion that tie us to the entire galaxy. The same physics that flung 3IATLAS from its home system billions of years ago are still at work today, moving dust, asteroids, and perhaps even the raw ingredients for life across the stars. In a universe that vast, connection isn't the exception. It's the rule. And yet, for all its scientific value, the story of 3IATLAS is also one of emotion. A cosmic epilogue about impermanence and perspective. Here was an object that had survived the void, carried the secrets of another sun, and crossed the distances we can barely comprehend, only to crumble under the light of ours. Its life as a solid object ended in our sky. But its legacy continued in our understanding. In falling apart, it revealed how intertwined existence really is. When astronomers looked up at 3IATLAS, they weren't just seeing a comet from another star. They were seeing a mirror, one that reflected our own fragility, our own wanderlust, and our shared origins with everything that shines above us. That's what science does at its best. It reminds us that knowledge and wonder are the same thing seen from different angles. In the end, 3IATLAS didn't stay long. It didn't orbit our sun. It didn't leave a trail of mystery behind, like Oumuamua. And it didn't announce its arrival with spectacle. It came, it brightened, it broke apart, and it kept moving. But in that fleeting encounter, it gave us something more profound than permanence, a glimpse of connection. It reminded us that the cosmos isn't out there, beyond reach. It's here, woven through everything we are and everything we'll ever discover. The dust of alien worlds falls on ours. The light from other suns warms our telescopes. The space between stars isn't a barrier, it's a bridge. 3IATLAS may have come and gone, but it left us a message written in starlight. The universe is not out there. It's already passing through. And maybe that's the most extraordinary realization of all, that in watching a stranger from the stars, we finally recognized the family resemblance.